Hello, my dear student. I'm Saktwala from Educators. I will be with you in physics for Form 5. Now, today, my dear student, we are going to proceed with our discussion on our topic as we observe here for our subtopic of the gravitation. So, my dear student, before we proceed with our discussion here, now we are supposed to remember where we ended on the last session. On the last session, we tried to see the concept of the gravitational field and the field strength. And after there, we see some parts, some concept related with the gravitational field and also the field strength. We have tried to see Roman A, which give us the gravitational potential and also the potential energy. That is what we try to see on the last session. We said that, my dear student, this gravitational potential, this is the work done required to bring the mass from a certain point, from infinity to a certain point. Kwamba na tukasema kwamba we imagine that always the point the distance from point A must be approximated to 0, kwa sababu tunasema kwamba 1 over RA, kwa sababu yupo kwenye point at the infinity, RA at imply to infinity. 1 divided by infinity is equal to 0. That is what we tried to see on the last session. And we obtained that the gravitational potential must be equal to negative GME divided by R, while the gravitational potential, this is the work done is equal to the work done. It means we obtain it by taking the gravitational potential times the mass. This is what we try to see on the last session. So on our session here, today we are going to proceed with Roman B. This give us the relationship between the gravitational field strength and also the gravitational field potential. So we have tried to see about the gravitational field strength and also the gravitational potential. Now let us go and see how these are related, my dear students. How these two parts are related: the gravitational field strength and also this gravitational potential. How they are related is what we are going to see on our discussion here. So the gravitational field strength on the Earth's surface is given by G is equal to GME divided by R square. We say that we obtain the gravitational field strength by taking the work done divided by the mass of the body. And we try to demonstrate that if we substitute the formula of the work done, we obtain that work done must be equal to the gravitational force times the small distance. And if we press there and apply integration, and if we substitute there and divide by the mass of the body, now we should obtain gravitational field strength equals to GME divided by R squared. This is what we try to see on the last session. So gravitational potential on the Earth's surface is given by here. So let us recall the formula of the gravitational potential. After seeing the formula of the gravitational field strength, now we try to see on the last session that the gravitational potential must be equals to negative GME divided by R. This is our formula here. So how these are related, this is what we are going to see here. So my dear student, let us divide the two equation and solving for G. We have our first equation here, which give us the meaning of the gravitational field strength. But the second is the equation of the gravitational potential. Now we are supposed to take this equation and divide it by this equation. And after there, we supposed to make a G at the subject. G ambayo represent the gravitational field strength. So if we divide, we should obtain that this gravitational field must be equal to negative gravitational potential divided by R, kwa sababu ukigawanya hapa, ukichukua huyu ukagawanya huyu GME ni common, ataweza kucancel, lakini kuna R square hapa, huyu mmoja wapo ata cancel. Akisha cancel, tunabakiwa naye ni nani? Tunabakiwa naye G divided by this V must be equal to negative ya 1 over R. But we are supposed to make G at the subject. We should cross by V throughout. If we cross V, if we multiply by V throughout, the V should be cancelled at the left side and shifted into the right side. And finally, we obtain this gravitational field strength, which is equal to negative V divided by R. So this will be our formula. Itakuwa ni formula inayotupatia the relationship between the gravitational field strength and also the gravitational field strength and also this gravitational potential. Kwa hiyo ndio itakuwa kama tunavyoona, huyu G ana represent the gravitational field, lakini huyu V ana represent the gravitational potential. R represent the distance that should exert between two masses ambao wataweza kuexert pale. So for small changes, so let us indicate for the small change. It means for the small change, this should be dV. Kwa tumepata G is equal to the gravitational potential divided by the distance. Now for the small change, we say that gravitational potential must be equal to negative derivative of V, derivative of gravitational potential divided by the derivative of the distance R. As we try to observe here for small change, watakuwa ni dV dr, ndio tunapojaribu ku observe hapa. Thus the gravitational field strength G is also called the negative gravitational potential gradient. Kwa this gravitational field strength sometimes tunaita ni negative gravitational potential gradient, kwa sababu hii hapa inatupatia ni gradient, ili tuweze kumpata huyu gravitation field ni sawa na negative ya ule gravitational potential gradient. It means ni sawa na gradient derivative of V divided by derivative of R. It means we take the final V2 V2 minus V1 over R2 minus R1. Kwa itatupatia gradient, lakini yule gradient atakuwa ni negative as we try to observe here. So after this, my dear student, let us come back and look at the examples related with what we try to see, related with the gravitational field strength and also the gravitational potential, finally with the gravitational potential energy. This is what we are going to see our example here. So our example, as we observe here, say that calculate the gravitational intensity on the surface of mass, assuming it to be a uniform sphere of mass this one, and the radius of this one. Use G is equal to this one. So here we are supposed to go and find and calculate the gravitational potential, the gravitational intensity. Gravitational intensity ni sawa na gravitational field strength. Ndio kitu ambao tumeambiwa tuweze kucalculate hapa, the gravitational strength here, or the gravitational intensity. If we have the mass of the mass, kwamba hii gravitational intensity ni gravitation iliyoweza kuhitajika kuweza kuitoa ile mass from the center point mpaka kwenye the S, the center of the S, au ile iliyo exact between the mass, huyu mass it means planets ambao ni mass kati ya mass pamoja na huyu AS, tunaona pale ndo gravitational intensity ambayo tumeulizwa hapa. So before we solve this question, we are supposed to summarize the data that we have on our question here. On our question, my dear student, we have the mass, the mass of the mass, kama tunavyoona mass of the mass of these planets. Tunaye ni sasa na 6.4 exponent 22 kg. And finally we have the radius. Tuna radius radius ambao aliweza kuexert pale kwamba from the earth mpaka kwenye ile pointi ambao tulikuwa tumesha ambapo mpaka kwenye ile pointi ambayo saili ya math ilipokuwa pale. Finally we have the g. It means we have been given the g. G always ni constant ambayo ni gravitational, ni universal gravitational constant ni 6.67 exponent -11. It is unit is a Newton per meter kilogram, Newton meter square per unit kilogram square. So how can we demonstrate this question here? How can we solve this question, my dear students? First of all, we are supposed to recall the formula of the gravitational field strength. So we say that gravitational field intensity au gravitational field strength ambao sana sana tunaita hizi zinakuwa zina relate. Kwa hiyo ukiambiwa kutafuta gravitational field strength ni sawa na gravitational intensity. Kwa maana tumesema tangu mwanzoni kwamba yule gravitational field strength, yule weki ndani pamoja na distance anayohitajika pale, anaye exert kati ya mass fulani na mass nyingine. It means ana exert kati ya mass of the mass of that planets and also the Earth. Therefore, our formula here should be gravitational intensity must be equal to GMS. This M represent the mass of the month that we have been given, which is equal to 6.4 exponent 22 kg. So here, my dear student, we are supposed to substitute our given value. Kwa tunachotakiwa sasa baada ya kuandika formula ya G is equal to GM divided by R square. Now we should take our value and substitute into our formula here. Kwa tukisubstitute pale tutapata sasa kumbe G must be equals sehemu ambao kuna huyu G constant ambao ni universal gravitational constant, tutaweka value yake ni 6.67 exponent -11. While the place where there is the mass which is equal to 6.4 exponent 22 and divided by the radius. Radius we have this radius we have which is equal to 3.375 exponent 6 meter. Then we put a bracket and put it is exponents ambao tumepewa kwenye ipo kwenye formula. So after there, my dear student, you have to take your calculator, and after taking your calculator, try to solve this question. There are two methods that you can use here: the direct method and also the indirect method. Direct method ni method ambayo tunaenda moja kwa moja. Kwa utaandika bracket alafu utachukua G zidisha kwa value wa mass, na baada hapo uta cross ile bracket, divide, utaweka bracket ya ile value of the radius, then we cross the bracket and put the exponent. Utapata jibu moja kwa moja. Au kwenye indirect method we should start in find the value of the numerator. Baada ya kupata value ya numerator tutakuja tutatafuta value ya denominator. Mwisho wa siku tutazigawanya hizo numerator divided by the denominator. You should obtain the value of G, the value of the gravitational intensity, which is equal to 0.375 Newton per kilogram. Ni Newton per kilogram, and if we express tupata ni sawasawa na 0.375. It means exponent unit yake itakuwa ni meter per second square au ni Newton per kilogram. This should be our form, our unit. So after there we should conclude by saying that the gravitational field, the gravitational intensity on the surface of Mars is equal to 0.375 Newton per kilogram. This should be our unit here. So number 3 here, example number 3.23. Our example number 23 here say that calculate the distance from the AC to the point where the gravitational field due to the AC and the moon cancel out. Kwa swali letu linataka tuweze kucalculate distance from the AC to the point where huyu gravitational field gravitational field due to the earth and also the moon cancel out. Kwa hiyo tunatakiwa tuweze kutafuta the distance that exact that make it the gravitational field to be cancelled throughout between the earth and also the moon. But we have been given the earth moon distance is equal to 3.8 exponent 8. The distance that exact between the moon, between the earth to the moon is equal to this value, 3.8 exponent 8 meter. And the mass of the earth is equal to 81 times that of the moon. Kwa hiyo tumepewa yule mass of the earth ni sawasawa na 81 ukizidisha na yule mass of the moon. That is what we have been given into our equation here. So finally, my dear student, what we can do here, because we are supposed to find the distance from the earth to the point where the gravitational field due to the earth and the moon should be cancelled out. How can we find that distance? So here, my dear student, it's not a difficult question here. First of all, we are supposed to summarize the data that we have into our equation here. We have the mass of the earth, which is equal to 81 times the mass of the moon. And also we have the distance that is exact between the earth and also the moon. How can we find that? So the solution here, first of all, we are supposed to relate that. X represents the distance from the earth where the resultant gravitational field strength cancelled out. Kwa yule x ata experience kwamba yule ni yule distance kutoka kwenye earth pale ambapo yule resultant gravitational field strength atabini cancelled. And suppose a unit mass m is put at this point. Kwa kitu ambacho tutakuwa tuweze ku imagine kwamba huyu unit mass m is put to this point. Consider the figure. Let us consider our figure here. On our figure, my dear student, we have two objects. We have the earth and also we have the moon. The moon tried to move around the earth. They tried to rotate around the earth. But at a certain point, we see that the moon is exactly at the same on a straight line with that the earth horizontally, as we can try to see here. This must be the earth and this must represent the moon. But this is our mass here, mass m, as we try to see that occur between the moon and also the earth. The distance between the mass and also to this mass here, m, which is unknown, we have which is equal to 3.8 exponent 8 minus negative x. Kwa tutakachokifanya kwanza, distance from the earth mpaka kwenye ile mass ilivyokuwa imewekwa pale, tutaleti ni sawa na x, lakini distance between these two mass of the moon and also the mass of the earth tumepewa ni 3.8 exponent 8. Kama hapa kutoka hapa kuja hapa ni x, sasa hapa itakuwa ni ngapi? Basi itakuwa ni 3.8 exponent 8 minus this value of x. So this is our figure that represents the distance between the earth and also the moon. So how can we solve this question, my dear students? Gravitational field strength cancel out at this one. We have to make a comparison that the gravitational field strength of the earth must be equal to the gravitational field strength of the moon. We have to make a comparison kwamba huyu gravitational field strength aliye exact hapa na yule aliye exact pale ni sawa. Kwa hiyo lazima tuweze kuwa equate kwa sababu wabini cancelled out. So after there, substitute our formula. Gravitational field strength of the earth must be equal to gme divided by x square, kwa sababu x ndo distance aliye act kati ya mass m pamoja na mass of the earth is equal to the g bracket the mass of the moon time divided by this distance of between the moon and also the mass m. So after there, my dear student, use the concept that mass of the AC must be equal to 81 the mass of the moon. Kwa tukimsubstitute hapa wata cancel out. Mwisho wa siku tutapata yule distance ambayo alisababisha ile resultant gravitational field strength awe bini cancelled. Tutaweza kumpata ni sasa 3.42 exponent 8 meter. And after there we should conclude by saying that therefore